Welcome to
Yes, sir, we
InfoSec
can.
Train, guys. My name is Bharat, and I'm Information Security Consultant and Trainer at InfoSec Train. I do have near about 8 years of experience into total field of information security, and the core part, if I talk about, I do have 10 plus years of experience of information security and 1 plus years of experience of your IT, right? And the domain which I do have my major competencies, it would be my testing part, right? So I'm the person who is moreover technical person instead of the management side, right? So I do have my more core area over the testing side, right? So I do multiple different types of testing, includes web, network, application, and all the different types of testing, I would say, right? So this is a just little introduction about myself, and this is just overview of my profile. So if you see over here, I have basically attempted the major flavors of information security's technical part, be it OSINT, be it digital forensics, be it threat intelligence, be it web applications, be it your networks, be it your pen testing, right? So I do have covered majorly all the different sides of information security so far in my career. Then if I talk about the qualifications, these are few of the certifications which I do have in my profile, which starts from the EC Council certified instructor and then conduct like having all the major certificates from EC Council, like one of the famous belt of EC Council I have covered, plus CompTIA's three major security certifications also I do have with me, right? Then I talk about the technical skills. You see, majorly I do have my technical skills in core area of pen testing over here, right? Be it different types of testing. So I do basically have like the major area where we talk about testing itself, right? So these are few of the batches in front of me, and this is the clientele which I have built so far in my career. Now let me take you guys to the brief of today's topic. So networks, the ground zero for all communication, right? This is how we will be taking this 1 hour webinar, guys. We will be starting with the topics which we have to discuss. I will be showcasing you some cool stuff, and then we will be discussing the questions, right? So that's what we will be discussing today. Just a little overview about our company over here, InfoSec Train. We are into this field of IT security trainings from last 4 plus years. This will be our fifth year over here, and we do have trainers who do have various majority of experience of 15 to 20 years of experience into industry, right? And these are like few of the numbers which we have gained so far in just a short time span of 4 years. Now, this will be our today's agenda, which you guys, all of you guys might already know since you guys have registered over here. So this is our agenda for today's discussion. It's not like that the knowledge will be limited to these topics. These are just an overview. So we'll be wrapping up the slides and then I will be taking you to the some practical cases, right? So we start with introduction to networks, right? We were discussing that networks means to connect to devices, right? So networking, basically, if I talk about networking, it is like we can say that the path which is used for all the types of communication, be it device to device, server to device, endpoints to appliances, everything is being configured with networks, right? So networking is very useful for us and is very important. We will be understanding why networking is important for us in order to survive and sustain this technology, right? Which is immediately like drastically changing itself and emerging into new ones after every coming day, right? So let's start with the today's session, OSI model, right? We do have OSI model, which is one of our reference model, right? Whenever we talk about networks, we do hear this word, right? OSI model, isn't it? So when we talk about OSI model is one of your models which can be used or which is being used to lay out the reference, right? How we do communicate in the network, right? So your OSI model, if we talk about, it starts with 7 layers, right? Mostly, guys, I have seen people having a little bit of trouble in remembering all these 7 layers, right? Starting from physical layer 1 till application the layer 7, right? People do have a lot of, I would say, trouble in remembering these layers, right? All those who are working in network, they knows that what thing works over where, so they do have knowledge about it. But all the new ones who are new to networking and security, I would say they do have a lot of trouble in understanding these layers, right? Or to remember these layers, and that too in a sequence, right? So I do have one liner for all of these 7 layers which you can use in order to remember these 7 layers, right? And that is very relatable, I would say, to your actual real life, because most of us over here have heard about the term pizza and sausages, isn't it? So that is what, whenever you will be going for a pizza or sausage, next time you will be definitely remembering the OSI model, right? So we start with physical. Physical is for please. Data link is do. Network is not. Transport is throw. Session is sausage. Presentation is pizza. And application is away. Now, when you recite this from bottom to up, it makes up please do not throw sausage pizza away, isn't it? So one of the most easiest way I would say in order to remember these OSI layers, and that too in a sequence, right? So now why OSI model is basically like one of the model which we do not implement. Like we all know that OSI model is a reference model, right? We do not use this in real life. Any idea why we do not use this OSI model as a reference model in real? We use it as a reference model and not a model which on which the networking can be implemented. Just we take it as a reference. The reason is that increasing use of technology made it very difficult for an OSI model in order to basically remember and in order to implement it in our real networks, right? So that's why we do not use OSI model for communicating, and it is just being used as a reference model. We do have a different model which we use for communication that will be coming in our next slide. Let's just understand what these 7 layers are, which are in front of us, right? Layer 1 is your physical layer. Anyone, any idea what is physical layer and what is the use of physical layer, I would say? It connects the devices, it transfers the raw bits, physical connection where data is shared in bits. Absolutely correct. So that is the use of physical layers, like the things which you can touch, isn't it? Like you do have your RJ45 connectors, right, which you use in your broadband or DSL modems, right? So the wires and all the Ethernet cables which you see, these are the part of physical layer, right? Then we do have data link. So data link layer basically shares the frame with the headers. Absolutely correct. It works on the MAC address, right? Your physical address, I would say, it works on that, right? Your MAC address works over here, your ARP. I would not say entire ARP, the part of ARP even works over here, right? Transfers and receive the information over network, right? Then the third layer is your network layer. If we talk about, any idea what does the network layer works on? So when we talk about path determination and logical addressing, over here we do give the IP addresses, right? We do have the IP addresses, the senders and the receivers IP addresses are being attached over here, right? So that is use of your network layer. Then we talk about transport layer. It uses protocols like TCP and UDP, and it takes the data from one part to another. End-to-end connections and reliability is being established on your transport layer, right? It also basically breaks your packets into the segments, right? So that is the use of your transport layer, right? Then the next one is your session layer. It controls the sessions, right? So just as an example, when you log in into a Facebook account, right? You do have Facebook account. I believe most of us over here will be having Facebook account. When you do log in into Facebook account, you do have created a session on that particular website, isn't it? Like Facebook knows that this is Bharat, right? If Bharat logs in into a Facebook account, Facebook knows that this is Bharat and this is his account, right? Now, what activity is being done on Facebook at that particular part? It will be from the Bharat's end, right? Because of that particular session, Facebook identifies us and it gives us the name, right? So session. Then you do have the presentation in front of you, the second last layer, presentation, right? Presentation is morely responsible for encryption and decryption, right? So that is the use of presentation. It encrypts and decrypts the data, right? Then we do have last layer. This is where we all are sitting over here right now. This is where we generally do work, right? So if anyone asks you a question that which layer among all of these is closest to the user, right? So it will be your application layer, which will be your end user layer, which will be closest to the user in terms of transmitting also and in terms of receiving also, right? That is your application layer. Just like your browser is one of the example of your application layer, right? So that is your OSI model. And there were a lot of, I would say, like complications in order to implement OSI model, because application, say, presentation, session, all these were working side by side, because it's not like that you give the data then it's being encrypted. Everything was being working side by side, session was being given side by side. So it was very impractical for us to implement this OSI model. That's why we came to a new model, that is your TCP IP model, right, which we used instead of OSI model, right? Your OSI does have 7 layers and your TCP IP do have only 4 layers, right? And how do we map OSI and TCP IP model? We do have first 2 layers of OSI model, physical and data link, which is mapped as link layer. In some books, you will also see it as a network access layer, right? Then you do have network layer, which is your internet layer. Various book have different names for it as well. So that is your network layer. Now transport being for transport itself, and we have combined the last 3 layers of OSI model into one header, that is application layer, right? So application, presentation, and session, all three are the combination of your application layer, right? So that is your TCP IP model, and this is what it's being implemented in our networking, right? This is what we use in our networking. Understood? OSI basically is just your reference model. That's why we do not use OSI model and we go for TCP IP model. Because of implementation, it's entirely impractical to implement OSI into the working, right? That's why we go for TCP IP model. So that's your TCP IP model, right? Then our next thing is, right, network topologies, right? So in front of you, you guys see an image that is of bus topology. Before understanding bus topology, let's understand what are topologies. Topologies are your representation of your network, right? How you are managing your network, how your network devices are connected. That's what we call topologies, right? So we do have various different type of topologies, and we will be talking a one liner for each topology in order to understand different famous types of topologies, right? So our number one over here is bus topology, right? Bus topology, this particular line is the line which is known as your backbone line, right? Backbone cable. And with this backbone cable, each device is connected to itself, right? So that is your bus topology. All devices are connected to one single common wire, right? It is easy to install because each cable needs to be connected with just one cable, that is your backbone cable, right? So that is your bus topology, right? Then the next one we do have is your star topology, right? Star, as the name suggests, star, we will be having the data in a particular format where there will be a centralized unit, right? Just like we have taken an example of switch over here, we can have hub as well, right? But in case of hub, the data will be always broadcasted, which not happens in switch. So if A over here wants to send the data to D, it will be using this path, which will be through switch and going through D, right? Or if let's say F want to send the packet to B, it will be again the switch which will be the intermediate for receiving and sending the data, right? So there is a central part which is forwarding the every data, right? That is known as your star, right? The features can be like it is very less expensive because every device will be needing just one input output port in order to connect with hub, right? With one link, and then they can share the data to anyone over there, right? So that is your star topology, right? Then the next one is your ring topology, right? You do have ring topology over here. So ring topology, just like the circular format you see over here, every device is connected in a ring format, right? So if I want to send a data from A to D, I have to send it through B and C, right? So the management is easier. If I want to add a device, let's say over here, I just have to break the cable over here, put a wire of that particular device, and I can attach a device over here, right? So the management is a lot easy in this particular type of topology, right? So that's your ring topology, and then we do have mesh topology, one of the fastest topology among all, right? Because every device is connected to each other, right? And if one link fails, it will still, the data will still be transmitted to another ways, right? Like just as in assuming if A wants to send the data to C, and due to some reason direct link is broken, A can either go to D and then share the data to C. If this link is also broken, it do have the B via C. If this is also broken, then the last will be your via E and D and then C, right? So over here, the data transmission will never be stopped, right? Everyone will be connected to each other in multiple ways. So data transmission will never fail over here. And secondly, there will be no data traffic. Reason? Every device is connected to each other. So over here, B is connected to E directly. So there will be no traffic in the links, dedicated links between two devices, right? So that is your mesh topology. Then you do have hybrid one. Hybrid means the combination of two or more topologies, right? So hybrid means the combination of two or more different types of topologies, which makes it as a hybrid, right? So over here we have taken an analogy to discuss the hybrid topology, which is star plus bus, right? So you do have a system which do have two different networks, right? Network B, network C, and all of these networks do have different devices with them, right? So this particular part over here makes it as a star, this part also makes it as a star, right? And these two where they are connected, these are your bus, right? Just like if scalabilities are concerned, this particular type of hybrid methodology where it includes bus plus star will be very efficient for us in order to increase the devices, right? So that is your hybrid topologies, right? So we do have the basics of topologies in front of us. Now what we'll be talking is IP addressing, which is another point from our agenda, right? IP addressing, when I start about IP addressing, I do have a question for all of you guys. There are IPv4s, right? Everyone knows IPv4. This particular part is an example of IPv4 address, right? Then you do have IPv6, right? Hexadecimal notation. Can you guys tell me why we jumped from 4 to 6 directly? Where is IPv5? IPv6 was never being used, first of all. It was just being in the testing part and in the developing part. The idea was to use it for the streaming part, but into the environment of the production, but it never came up and it died itself on the I would say, like, it was in the testing part, neither for, I would say, streaming. Just in the testing, when we were analyzing whether we have to use IPv5 or not, we have denied it over there itself, right? It never came to life. So we shifted to IPv6 because it was giving us much more IP address. Now the reason why we have to move from IPv4 to IPv6, it was due to increase of devices. Earlier, if you see, when the networking started, the IP addressing was enough for us, right? But now if you see, every person is carrying at least 3 to 4 gadgets with them, right? Each of them is having IP addresses, right? So if I say every person will be having a tablet, will be having a mobile phone, a smartwatch, a laptop, right? These kind of things everyone is having, right? Increase in IoT devices, everyone is having the IP addresses with them, I would say, instead of devices, because each device is having an IP address. So we were running short of IP addresses, though are able to fulfill the need as of now, we are able to cater, but in near future, if you even if we think, we will not be able to cater the need, right? So that's why IPv6 was introduced, and IPv6 basically came as an IP address version 6, which was giving us a lot and a lot of IP addresses, which even everyone has like 10 to 12 IP addresses, even it won't be like full, right? So that's why we came IPv6 into the pictures, though IPv6 is not yet widely being accepted, but the future will be moving towards IPv6 only, right? So let's discuss a little about IPv4, which is our topic of area. So when I talk about IPv4, guys, IPv4 is your 2 to the power 32 bits of IP address, right? So when I say 2 to the power 32 bit of IP address, basically this is what I meant, right? So 32 bits are there, which are divided into four different octets: 1, 2, 3, and 4, right? Now over here you are seeing two things. This one is binary, isn't it? And this one is your decimal notation, which you see over here, right? Why we use decimal notation is, like, if I ask you guys to remember this 101011000001 and all of these binaries, it won't be very easy for a human to remember these binaries, right? So what we did was we basically converted this binary into the decimal form, and now we are using this particular decimal form over here in order to remember the IP addresses, right? So the entire idea about this 2 to the power 32-bit IP addressing is that we do have four different octets, which are basically summing up to the 32 bits, because 8 bit of one octet is there, right? So if I say 8 bit of one octet, here it is in front of you guys, right? And your IP address is basically IP address IPv4. It does have various different classes as well, right? So we do have different classes in front of us. The one is class A, then we do have B, we do have C, D, and E, right? 0 to 127. Can you tell me, out of 0 to 127, if I write 0 over here and 127 over here, how much usable IP addresses are over here in this class A? We do only use from 1 to 126, right? Instead of 0 to 127. Yes, the correct range is 0 to 127, but the only usable IP addresses, if we talk about, it is 1 to 126. Reason we do not use 0 and 127, there is sometimes our system basically does not know that where they have to send the data, right? So we use 0.0.0.0, which is a reserved IP address, which we add to the packet and we send it to our router, and then our router basically decides that to whom we have to send this packet, right? And 127, it's your loopback IP address. It is being used to check your NICs. It is being used to check whether TCP IP is properly implemented into your system or not, right? So 127 is your loopback. Then B's range is 128 till 191, right? Then C's range is 192 till 223, right? And then we do have D's range, which starts from 224 till 239, and E's range is your 240 till 255. And one thing I will tell you guys, that we do not use basically this particular ranges, last two ranges, that is D and E. The reason why we do not use these last two ranges is these are being used for experimental purposes, right? The one is for D is for multicasting, and E is used for experimental purposes, right? And these are the only three classes which we use in our IPv4 address, right? Class A, class B, and class C. So that is just a bit of overview for all of you guys for IPv4, and later these in details you will be understanding that how you calculate IPv4 addresses, how you calculate the subnets and everything later down when you go for any of the networking courses, right? So that is just an overview of IP addressing, right? Then the last topic, theoretical topic, I would say, which is for your importance of networks. Now, let me relate you guys the importance of network to real life. Over here, out of these 65, 70 people, we do have people who are working in cloud, right? So people who are working in cloud, guys, you also use networks, right? People who are working in testing, even you guys also use network, right? People who are working in threat intel, people who are working in forensics, all of you guys are having networks over your places, right? Anyone who is using a system and an internet connection is working with networks, right? So that's what make it a more relevant. If I talk about like networks importance, provides the best way of business communication, right? Using network only, we are able to work in this C19 situation, right? If it was not networking or the network people who had made the network so much stronger and robust, we wouldn't have basically able to survive our businesses into this pandemic of COVID-19, right? Then it does have streamline communication. Streamline communication, that means you can streamline your businesses, right? You can have a different communication channel for your salesperson, different communication channel for your consumers, and that is how you can divide your part with the help of networks, right? And of course it is cost effective. If I ask you guys to, if I you have to communicate someone sitting in US, so which one will be more feasible, giving him a ISD call or going over US and talking to him in personal, right? So it is a very cost effective resource sharing, right? There are a multiple, I would say, like importance of networks and fundamentals of networks. If I talk about, there are multiple things which helps the networks or which helps us because of networks only, right? So these are like few of the basics of the networks which were in today's agenda which we have covered. Now basically we will be talking about a small practical, right? What I am intended to show you guys is a practical where we will be just capturing the HTTP request and we will be analyzing it with a packet analyzer tool, right? I believe most of you people have heard about WireShark. So perfect. WireShark is, guys, your packet analyzer, or I would say protocol analyzer tool, which is being used for network traffic analysis, right? It itself is that much deep dive that you can definitely understand or definitely have a different course on Wireshark, right? Like we do have at InfoSec Train a different course for separately just for understanding Wireshark, right? So when we talk about Wireshark, Wireshark is one of the good tools, and we do have various alternatives of Wireshark these days, right? Like TCP dump is one of the CLI version of Wireshark, right? So anyone who is not fan of GUIs, right, they can go for TCP dump, which is a CLI version of Wireshark. You do have T-Shark, and then for these, I would say VoIP. These days, calls and everything are going on VoIP, right? Voice over Internet Protocol, right? We do have WireShark and multiple different tools available in the market, right? So just I'm doing over here, what I'm doing is I am just visiting a website. Now if you see, I just visited this website and how much traffic this is being created over here for me over here to visit a website, right? So instead of like this traffic, I will be starting a new capture, right? And then we will be going to sign in page, right? And over here we will be just signing it as a admin, right? Now let's go to Wireshark over here and let's see if we are able to find something interesting for us, right? So what I'll do is I'll stop this request. I'll go to the filters of Wireshark. I'll filter out all the HTTP packets and I'll find some data which might have been submitted something, right? So I do have this particular data, do login. What I'll do is I'll analyze this particular packet. If you see, it gives me all the information, right? It gives me the host name, the user agent, like the Mozilla Firefox I was using, right? And the entire request being transmitted over here. Since the request was in HTTP format, I do have even the session ID of that particular person. So a lot of information I do find it over here, right? So you do have the entire cookie when you are logging in and you are finding the data, right? So what you can do is you can go ahead and you can give it a try to Wireshark where you can find multiple details, right? If you analyze each of these packets, I believe there are very less number of packets, right? So when you analyze each of these packets, you will be getting the exact username and password which were being used over there, right? For logging in. So when you scroll down in this, you will be getting your data which was being used to log in, right? This is your entire request being captured over here with the Wireshark, right? Or else what you can do is you can go over here, you can go for export objects and you can export on the basis of HTTP, right? So multiple ways over here for extracting the HTTP traffic, right? So that is just one of the very smallest use case for WireShark, right? So that's your WireShark, guys. And in our courses like Network Plus, CND, we do use real life scenarios and case studies in order to basically analyze more things with WireShark, right? HTTP is just one of the smallest part which we do have over here, right? Apart from it, we do have various different deep analysis in WireShark where we do start with the very basic, which is your ping, right? We start with ping, we do ICMP packet analysis, we do understand that what exactly is being shown, what is going over there, right? So that was just an overview. Since it's just a 60 minutes lecture, I just wanted to give you guys a taste of tool known as Wireshark, right? Now, why InfoSec train? We do have various different USPs which you won't be finding anywhere over the, I would say, industry, right? So there are lot of, I would say, USPs. So anyone having any kind of inquiry regarding any of the courses, you guys can reach at InfoSec train, right? Or else you can mail at sales@infosectrain.com, right? And this is like just our trusted clients where we do have, and I do have received the options in chat like from where we can get training, right? So ma'am, for that particular purpose you can visit www.infosectrain.com, and we will be over there helping you regarding all of your training requirements, right? You guys can note down these numbers or the email address and the website which is in front of you, right? And hope to see you guys over at InfoSec Train. So, all right, guys, that will be all for us then today. If there aren't any other questions, if there are, we can discuss it over here. Else, we will be having off for this particular webinar, right? All right, everyone. So that's all will be for today. I hope to see you guys soon at InfoSec Train. Thank you so much. Have a nice day. Have a good night. Thank you.